Hello, my name is Eric Eichhoff, and I serve as the Associate Director of Alumni Relations at John Carroll University. Thank you for joining us. Today, you will learn about one area of research that is being conducted by John Carroll University's outstanding faculty. We hope you enjoy the program. Before I turn it over to our faculty, I'd like to tell you a little bit more about the Grauel Faculty Fellowship. Each of these presentations are part of the research undertaken by members of the full-time tenured or tenure-track faculty who receive the George E. Grauel Faculty Fellowship. The fellowship is named after a former member of the Department of English who served the university in a variety of capacities from 1933 to 1967. A Grauel is John Carroll's version of a sabbatical. Faculty submit applications for a Grauel in the fall, and if successful, take their leave during the following academic year. Awardees have received compensation for a full semester, or should they prefer, half compensation for a full academic year. Grauel Fellowships contribute significantly to the professional development of our faculty and attract outstanding teacher scholars to John Carroll. Thank you again for joining us, and I hope you enjoyed the presentation.
All right, well, welcome. I am Bonnie Gunzenhauser. I am Dean of the College of Arts and Sciences here at John Carroll, and I am really delighted that you have joined us for what is a fascinating and timely conversation. The panel today is titled Life of the Party, Social Networks, Public Attention, and the Presidential Nomination Process. This comes out of interdisciplinary work among three of our illustrious faculty who will introduce themselves to you momentarily. And we also are thrilled to have some John Carroll alums with us who are interested in this topic broadly construed and who will ask some questions and share with us a little bit about how interdisciplinary work and data science and political science inform their life after graduation. So can I turn it over first to Professor Elizabeth Stiles?
Thank you, Dean Gunzenhauser, and I'm just so happy that you've invited us to this panel. And I, being a professor, just have a couple of slides. I would like to try to explain our approach. Nobody else in this, none of my co-authors have agreed to this this title, but this is the provisional title, and I just want to sort of point out that we have alums now who are published along in this research agenda as well. Patrick Grogan and Kate Finneran as well. They wrote these papers with us while they were students here. And so the way that I like to think about the research agenda is if you look at this hammer high meter, that is a good, I think, proxy for how you can think about public attention. That's really what we're trying to explain is public attention. And we think the amount of public attention that a candidate gets is going to be important to whether or not they win the primary nomination. And so just like this hammer high, it can go up, it can go down, but instead of it being determined by somebody, using his hammer at the fair and trying to do it, it is driven by the dynamics of networks. And what we mean by that is social networks. So there's you can think of each blue one as it's a node, and then each of the little connected things are the neighbors. And so basically, if there's more buzz about a candidate running through these networks, then we expect public attention to be higher, and that will help the candidate. And if the buzz is lower, then the candidate's campaign is not going to really get off the ground as much, and they'll have less chance of winning the primary election. And so how do preferences travel through these networks? We use a threshold model, which is from sociology. And basically the idea here is individuals have different preferences for voting for each candidate. And their preferences are met or not met by the proportion of their neighbors in the network that prefer that candidate. So it's all about who the people you are connected to and who the people you listen to are interested in, which, I mean, and that's basically our assumption. And this is just the last slide. That's one of the first point is to pass the buck on to my co-author Colin to talk about how well does this really explain how people vote, do we think, compared to other variables? But We do know empirically that voters have, on average, low amounts of information, and that they're not usually able to integrate the knowledge, the political knowledge that they do receive, or to resist it. So continual amounts of messaging from their network neighbors is, persuasive. So yes, we think that it really does explain how people vote. And I'd like to just sort of pass it on then, if you're okay with that, Dean.
I am okay with it. I think it might be, the topic is so exciting that you've launched right in, but can you tell us a little bit about yourself and your intellectual autobiography that brings you to this topic in the first place, so that we can pass it on to Colin?
Yes, of course. Sorry, yes. So I have a PhD in political science, and my work in my dissertation a million years ago was on social movements and how social movements activate. And so, we used to, we sort of thought about social movements very differently back then than we do now, because so much of it is online. And we can actually see how networks of activists or, political party, people interested in political parties are connected, and then how information travels through them. So I got very excited when I realized that we now have something that was only theoretical before, that we can now actually see on, in social networking.
Yeah, a lot of evolution in that approach over a short amount of time.
Mm-hmm.
And you have colleagues who are interested in this too. So Professor Colin Swearingen, can I turn it over to you next, please?
Absolutely. Thank you, Dean Gunzenhauser, for paneling this, or chairing this panel. So I'm Dr. Colin Swearingen. Like Dr. Stiles, I'm in the political science department. And I got interested in this topic of public attention in social networks, about a decade or so ago. I was still a graduate student and just had some conversations with a friend of mine in the program. And we were talking about, using public attention as a way to really describe a lot of things in the political process, but it wouldn't even have to be simply politics, right? I mean, he found this, my colleague found this by looking at, epidemiology. And so it's something that stuck out to him, and saying, well, what if we took a look at what people are Googling, right? Does that tell us what people are interested in? So that's where we kind of started here, to try to understand how this could apply to politics. And so my own research before we teamed up on this project focused on public attention in things like Senate races, as well as presidential primaries, in fundraising, performance on Super Tuesdays, but also working with Dr. Stiles and one of our alumni, Kate Finneran, on a paper that was recently published. And I'm going to go ahead and share my screen, as long as it works, to give you a little bit of a view as to kind of where this started off. For those of you who haven't done research in a long time, or haven't done any research, how it works, certainly in our discipline, I think it's very similar to other disciplines, is you take your research to a conference and you tell people about it, you get feedback, you change the things based on the feedback you get. So whether it's your statistical models, or maybe your theory, or maybe it's just your analysis, right? There are a lot of different places you get feedback. So we took this to one of the largest political science conferences in the country, the Midwest Political Science Association, and presented this a few years ago. And I'm not going to go through all of this, but this is just one example of a title, a statistical model. And what we did here is we just took a look at whether candidates were able to perform well in New Hampshire, right? It's one of those key primaries. And we use this public attention variable as one of the potential indicators for success. And so, what we ended up finding out was that it's a really great measure if you don't rely on polling. And now we also looked at this for other things, finding that public attention worked in conjunction with polling. But this is one of the things that stood out to me is, hey, what if we don't have polling information? Or in the case of 2016, right? What happens if the polls are wrong, leading, myself to be completely wrong as to who I think is going to win? So, when we take a look at information and data, part of the struggle is trying to find good information, good data, but getting it from multiple places or multiple types of data to help lead to some sort of explanation or prediction. So we found that public attention worked really well with this. And so we started then thinking about how we could take this from, an election level to something that was going to be more at the individual level. And how do you show public attention working among individuals? And that's where Elizabeth started talking about social networks. Let's start trying to model those things. So we can talk a little bit more about that, but I'm not the expert on social model networks. I think Dr. Linda Sider is, so I'll toss it her way.
Well, hello, I'm Dr. Sider. I'm Linda Sider. I'm in the computer science program, math and computer science. I'm not a political scientist, and before I worked with Dr. Stiles and Dr. Swearingen, I knew nothing about voting models and threshold models. But we met a few years ago when we were designing the interdisciplinary data science major, and that kind of kicked off our collaboration, getting to know each other and seeing kind of common ground in terms of data analytics across the two different disciplines. And so I had a lot of learning to do in working with Dr. Stiles and Dr. Swearingen. And that's basically the job of a computer scientist. You're often working with on projects on topics that you know nothing about. And so it involves a lot of learning and trying to understand their problem. Yes, it was a social network, but there's so many questions to ask. Dr. Stiles showed you a graph. Questions like, those edges between the graph, do they go one way or two ways? Are they weighted? Are the nodes weighted? Are there types? So just what kind of graphs are there? What kind of graph structures? So trying to understand all their rules is really, I think, the fun part of being a computer scientist. You get to always learn new stuff, and you're always learning new problems. And trying to take English and English descriptions, which are extremely ambiguous and vague, and turn them into something very, very concrete and something that you could actually implement. And so it's been a great learning experience for me, learning about a lot of. I found the whole threshold model initially just seemed so odd, because the thought that, and I guess again a lot of this got back to what kind of graphs we were going to model, and Dr. Stiles kept insisting that these were very simple. For the most part, people just have a few connections to, so the graphs tend to be very sparse, where each node is only really connected to a few. And I keep thinking, with social networks and social media, isn't everybody bombarded? Aren't there like tons and tons of connections? But yes, but do you actually listen to all of those? And so a lot of these issues initially in the design were based on their professional knowledge of social networks, at least in terms of voting types of influence. And so just, working with them, where they had to teach me their model well enough that I could actually implement it and build a model. So it's been, I love working with graphs, and so this has actually been a really fun project. A lot of fun graph algorithms that I had to dust off from the very dusty parts of my brain.
So part of the point of this panel is to talk about the particular piece of research that the three of you undertook together, and then more broadly, it's to talk a little bit about what are the joys and the challenges and the opportunities of doing interdisciplinary research of the kind that you're doing, and that's where I hope we can pull our alums into the conversation as well. But Linda, you just talked about all of the things you thought you had to learn from Colin and from Elizabeth in order to build this model that would help them to conduct this research. Elizabeth and Colin, I wonder if you can talk a little bit about what you learned from Linda's questions and how that helped you sort of refine your thinking, develop your thinking, advance your thinking as you worked through this project.
Well, it was, we learned a lot. I mean, I learned a lot. I mean, her darn questions made us specify a lot of things, and not everything in the theory is so clearly specified. So we often had to make judgment calls. And then, of course, we would be called upon to defend those later. So we really had to read up. It really made us go back to our literatures, I would say, and focus in on, some of her questions so that we could get this thing modeled. And I would also like to say that because of our association with Dr. Sider, that Colin and I have both taken Data Science 100 now, and I will be teaching my first section of that in the spring, which is somewhat terrifying, but but I know that she'll be there to help me along. But it really has been a great interdisciplinary work across research and teaching, I would say.
Mhm.
Yeah, and I also would add to that, one of the biggest things is being able to explain yourself clearly to somebody who doesn't have the same level of knowledge about a particular topic. And so it works both ways, right? I mean, I'm sure everybody that's out there, all of the alumni know what it's like to explain what you've been doing in your work to somebody who has really no clue. And it really forces you to think about not only the precision in language, but the ability to say it in a way that people understand. One of the things we struggle with as academics is being able to relate our stuff to what people are looking at, right? How do the layperson understand what we're trying to do? And we're not good at just saying, here's how it works. So that's been one of the biggest things, is just being able to communicate that information. And I also like to comment that I believe when I took Data 100, Ryan was in the class with me.
Oh.
So
I do remember that. That was a fun class. And just to kind of add on from a student perspective and how that can translate into my professional career, that notion of kind of having to translate your findings to maybe a non-technical group or somebody who maybe not know or understand the model, so to say. I've had to experience that in my role as a consultant for the last year and a half, creating data dashboards or data platforms, and having to kind of relay our findings from the data that we gathered to the client on maybe if it's market analysis or research. It's something that I think we learn the technical skills in the classroom, and you really get to see and understand and appreciate the value in actually translating those findings, translating the kind of the data science into a language where everyone can understand it. So just to kind of add on to that point.
No, thanks, Ryan. Can you tell us, Ryan, what you majored in and where specifically you're doing this consulting now? And then maybe we can pull our other two alums into the conversation as well.
Absolutely. So I'm Ryan Fitch. I graduated in 2019. I studied computer science with healthcare with a minor in statistics, but very much took a lot of the data science coursework under the data science major. And for the last year and a half, I served as a data engineer for a digital innovation consulting firm based in London, but just previously took a new job as a data engineer for a healthcare system. So kind of excited to learn more about the healthcare domain. And just as what Dr. Sider was pointing out, the ability to kind of use your technical knowledge to learn in maybe a new space. So healthcare informatics and the healthcare terminology. So maybe I can know what my doctors are talking about and the other clinicians. So yeah, that's all for me.
That's great. You're off to a great start. And it's light outside your window. So I gather you're not coming to us from London.
No, I am not. I'm at home in Chicago, and I was looking out at the snowflakes earlier. I'm very surprised to see those.
We could construct some models of whether we should have expected that, I guess.
Oh, absolutely.
Darlene, can you tell us a little bit about your time at John Carroll and what you have done since?
Yeah, so I am an alumni. I graduated in 2004. I had to think about that for a minute. Dr. Stiles was my top professor. I think I took every class that she ever offered. She was really, really good. I was a double major, poli sci, as well as sociology. Right now, I work at Kaiser Permanente. I negotiate contracts and I develop policies on behalf of Kaiser Permanente to look at our relationships with vendors. I actually have to leave this call in 10 minutes because what I do is I look at all of the data, look at how much money we're spending, look at what services vendors are providing us, and I make the argument if we need to reduce our spending or increase
Mhm.
our spending. And I work with a lot of people that are not. I don't want to say good at numbers, but they don't like for me to talk about numbers. So I have to put it in language that is friendly to them so they're receptive to it. So I take a lot of complex analysis, put it together, and then try to present it in a format that's easy for them to digest and for them to give me conclusions as to are we spending too much money with this vendor or we're not spending enough money with this vendor. So my time at John Carroll was really beneficial on learning how to do analysis, just developing relationships with people. So yeah, kind of what I do now.
So the world has changed a lot since 2004 to now.
It
How
has.
have you kept yourself current as you've moved through your employment in
Um,
terms of
s-
data skills?
so I also have a master's degree in sociology. So I took a lot of classes to help with my analysis there. With all of my jobs, because I did consulting work, it was a lot of on-the-job training. We have to continuously take, even at Kaiser Permanente, I have to continuously take educational classes to keep up to date. So it's just a lot of digestion of information, a lot of just trainings that I go to every single year.
And if I can put you on the spot specifically, you have anything to say about how John Carroll helped you learn how to learn in those kind of situations?
So, political science, it was not an easy major. It was a lot of just developing how to ask the right type of questions. So I think out of everything at John Carroll, just figuring out how to ask the right questions to learn what I need to learn, how to
Mhm.
reach out for assistance, building those relationships with people so you can go back and ask them for
Mhm.
assistance. I think that helped a lot.
That's a great answer. Learning how to ask the right questions is in
Mhm.
some ways what this whole project is about and what a
Yep.
lot of life is about. No, thank you. Kara, can we pull you into the conversation as well?
Absolutely. Um, I am Kara Mizaka Salzer. I also graduated in 2004. Yeah, Darlene, you do look familiar. I don't know that we actually know each other.
I was gonna say the same thing, but I didn't want to. I was like, I know her from somewhere. Okay, that makes so much sense. Thank you.
Yeah, it's been a long time. So my degree is also in political science, and I probably also took as many classes from Dr. Stiles as I possibly could. So we must have been in the same class together at some point or another. um, I'm going to jump right in and answer that question as well that Darlene answered about. I'm currently mostly volunteering, and I think that my education at John Carroll, specifically my degree in political science, has given me the critical thinking skills to really tackle any field that I'm working in or doing any volunteer work in, and the thinking outside the box, that whole person education that John Carroll is really about, and the thinking outside the box and the liberal arts is all just how you approach every different aspect of life. So I would agree with everything that Darlene said on that piece for sure.
All right. Well, thank you. So maybe we can circle back a little bit to the specific research project. You've talked some about your theory and the models behind networks and thresholds and predictive values. Can you talk a little bit more specifically about the case study of your article and what some of the key takeaways were from that?
I think Linda,
Oh,
is this
me?
a good Linda question?
Um, well, so our initial implementation was just having a network of voters. Each voter has a preference for some number of candidates. Actually, let me share the screen. It's probably easiest to show the model. Where is it? So we would model, in this case, voters as a network. Each node would represent a particular voter, and the edge indicates that these two voters have some kind of communication relationship. So again, initially I would ask lots of questions about, are these edges directed? Are they weighted? What does this relationship look like? And then we have some number of candidates, and each voter has a preference for a particular candidate, and then the threshold would be what percent of their neighbors would need to prefer a candidate for them to switch. And so, going from this model of voters and thresholds and networks, and implementing it using these sort of structures is kind of what the computer scientist does, comes up with actual models, matrices, and so on. So our initially we were just looking at I'll stop sharing, and Dr. Stiles and Dr. Swearingen jump in, but what kind of a lead would a candidate need in order to carry the vote, I guess. And pretty much it seemed to either be a candidate or undecided, right? In between was our initial, if some candidate didn't have enough of a lead, then everyone went undecided. And then we looked at pulling in decay, where you could think of it as, I guess Dr. Stiles said, people going on vacation where they're not communicating their preference as much, and what kind of an impact that would have on the model. We also looked at notions of true believers who will never ever change, and we see a lot of that these days, right? And what percent of true believers and how that impacts the results. And then I think, what else do we look at? A few other, well, currently we're looking at the notion of shock. I keep asking, is there any such thing anymore?
Right.
But basically, we looked at a lot of these different aspects of threshold, of preference, things that might influence basically the communication, the weighting of the communication, different types of graphs, different graph structures. Dr. Stiles and Swearingen could probably give a non-graph interpretation
of our findings. Sure. I mean, it's the model extensions. I mean, it really did quickly go down to a contest between, for us, the first candidate, the most popular candidate, and undecided. And that's one of the reasons why we decided to put, shocks into our next model, is because, we felt that I would say our chief finding showed that it really came down to, can the lead candidate close the deal, or is there enough uncertainty in the electorate that possibly with some sort of shock or other unexpected factor that the number 2 candidate might be able to sneak in and make an upset. And so that was our big finding. And then some of our other findings were, of course, the larger the candidate lead at the beginning, the harder it was to catch up I guess the easier it was for the lead candidate to close the deal. And the more true believers, of course, that's a big asset in a network. And then decay has an effect on the lead candidate, where it's harder for them to win. And those are all, I would say, sort of intuitive findings. It'll be interesting as we finish up our modeling and go to test this empirically, whether our intuitive findings will hold up or not. But I mean, I think, Colin has some preliminary results from our next paper that do sort of show some empirical validity. Do you want to
Yeah,
take?
well, I mean, this is top secret stuff, so you know.
It is.
No, but yeah, as I pull up the screen, it's a preliminary test. It's obviously research that's early in the process. But as Elizabeth mentioned, right? I mean, you talk about what are the key takeaways, and I look at it as if you got a lot of people who really, really, really love you, and they're not going anywhere, and they always talk about you, and you know, you got about 25 to 30%, you can do well as a front running candidate, which oddly makes me think of Donald Trump, right? I mean, that's where he was, the situation back in 2016. So in some ways, it's kind of interesting that, as Dr. Stiles said, like, oh, that's very intuitive, but a lot of people were not saying Donald Trump was going to win in 2016 for the Republican primaries. So I thought it was kind of interesting that, yeah, it may seem intuitive, but we oftentimes take a look at candidates that can fit that and then discount them for some reason, right? We always can find a way to kind of go against what the results say. And so, as they mentioned, both Linda and Elizabeth mentioned that, okay, well, what about shocks, right? What happens when something big happens? And so what we did is we took a look at some data for presidential primary candidates, those that were running between 2008 and 2016, in part because this is when we could get data from Google, you know, when it comes to presidential elections. It goes back to 2004, but, you know, we'd need data for 2003 to look at those candidates running for office then. And so we took a look at this, and what we found was that you can actually see how how public attention and how these potential shocks could lead to a change in support, right? So when we think about it in public attention terms, we want to know if more people are watching you, does that help you? And so we would think that a shock would increase eyeballs on your campaign. It would certainly increase people wanting to know more information about you. And so looking at a couple of different models, yeah, we see that, you know, for those who have taken the statistics course, asterisks are a good thing. They tell us that it's statistically significant, but we see that public attention can matter. We tested a couple different ways, whether it's, you know, whether it matters in that week that it happens, or if maybe it kicks in a week or two later. But we do see this positive relationship that if you get more eyeballs on your campaign, your polling goes up, which if you can sustain that momentum, then you can do something really interesting by the time you get to the time that votes start taking place in Iowa, New Hampshire, or if they change the primary process in the future, whenever those states take place. And to me, it really speaks to some of the ability of candidates like a Rick Santorum or a Mike Huckabee being able to get a lot of attention toward the end of this period to help them, you know, navigate a successful Iowa caucus on the Republican side, or even a Bernie Sanders when you look at his success in 2016, narrowly losing in Iowa. However, the Democrats calculated those state delegate equivalents. And then in New Hampshire, which of course was one of his neighboring states. So there's that momentum element that this can help us show. Now, again, early preliminary evidence here. It's not going to specifically test everything that we're talking about, but it is an interesting glimpse into that.
So this is a model, and the particular case that you're talking about in the initial article is the 2016 presidential primary, right? This maybe isn't a fair question, but how would this look different if you were trying to use it as a forward-looking predictive model as opposed to a sort of theoretical analytical model that you can test with empirical data that we have in hand because this is a past event? Would it look different?
I mean, I would say that as we move forward into 2024 and the next presidential primary, one of the things that we've seen in the past is, especially 2016 and 2020 on the Democratic side, a lot of candidates. And so when you think about the possibility for a front runner to emerge out of this pool, you would hopefully be able to see something that we talk about in this paper, help us predict who could, you know, come out of certainly the pre-primary period as the front runner. So a candidate that does have, you know, maybe not a ton of support, not the traditional 40 to 50% you might think of, but a candidate that has 20 to 30% could do well, again, if they really have that true, you know, true believers and they're able to get public attention on their side to stay above their opponents. And so we could actually take a look at that in 2024 to say, where are the candidates in polling, but where are they in public attention? And does that give them enough to sustain themselves throughout the span of, September, October, November, and into, 2024?
Yeah, no, that makes sense. Kara, I think you had a question.
Sure. Did you change the number of candidates that you used when you were doing the formula? Did the outcomes change drastically with an increased number of candidates, or did that not seem to affect the data?
Early on, we did try varying number of candidates, and initially, for the most part, we had one lead candidate. I think that was the seeds, what percent of the voters preferred them. And then the second and third, and however many after, were all kind of tied for second place. We varied things like the size of graph, the structure, the number of candidates, how much of a lead. It didn't seem to for the most part, it always seemed to boil down to either the candidate ahead won or undecided. We didn't really see anyone else sneaking. Occasionally, somebody else would win, but for the most part, it seemed to be that those two extremes. And even with talking about shocks, again, Dr. Stiles and Dr. Swearingen will talk about shocks but I have to always ask them, what does that mean? Can true believers be shocked? Ever? Just maybe occasionally, are only the undecided shocked? Is it affecting the threshold? How long does a shock last? Do we recover to the original threshold? So, and those are they're the ones that have to answer those questions. But I think, Ryan, you can agree the role of the computer scientists, right? Where we have to ask those questions, because it has to be incredibly specific, the specification. Otherwise, I'm just guessing, and I shouldn't be doing that, right?
Yeah, just to add on to that, Dr. Sire, I think through work with maybe doing market analysis, there's a big difference between being a consumer and a provider or a store for example. So it's easy to make assumptions, I think, but it's always good to double check. And at least in my experiences, my clients in the past, when I was at the firm, appreciated those questions and appreciated the clarification on some of the finer details, even when a assumption could be made about maybe a certain population or a certain demographic area for stores, so to say.
And the learning certainly, I think, went both ways. We had to learn each other's language. You guys had to learn how to read, a matrix and understand matrix multiplication and graphs, degrees, paths, and so on. And so there was, and I think that was kind of the fun part, was us learning how to talk to each other, being very different disciplines. But really you're not that different, right?
Yeah, I really have to agree with that. I felt like when I knew we had something was when Linda came over to the political science department, and Colin, and Linda sat in my office, and we started talking, and she started asking those questions, not as specifically yet, but just to try to understand the theory and the model. And we just started talking, and all of a sudden, maybe this is a reconstructed memory, but she kind of leans forward, and I was like, we've got something. It was all about, can we talk about this in a way that makes sense to all of us? And that's when I thought we could go forward.
Well, it's not very often the case that a bibliography is a particularly interesting part of an essay, but I was struck when I read your essay by the bibliography and the fact that it is so full of really sort of political science theory and modeling about election predictions, but theory untested by sort of the application of data and the way that you're doing it. And that's a really unique dimension, it seems to me, that the three of you are bringing to bear on this kind of project, and a real benefit of a deep and rich enough connection that you can talk across disciplines, not just across, but really to interweave them, right, in the way that you've done that here. So you've talked a little bit about what comes next, right, sort of refining this model to think about shocks, although I notice you still haven't exactly described what a shock is, so I would like to hear about that. And then I am curious if you have thoughts beyond that about what other kinds of collaborations, assuming world enough and time, you would like to try to engage in together. I think Kara has a question along those lines too, but let's start with shocks. What's a shock?
Oh, well, I mean, a shock could really be anything, couldn't it? I mean, if you think about all the ways that we've been shocked by politics in the last however long, it really could be anything. But I mean, I think we're trying to focus in on a couple of things that could be. Fortunately, Colin has a paper on scandals and gaffes that he that he calls Gandals, that is very helpful. You know, maybe something positive too. A shock could be positive. So maybe a particularly good fundraising quarter might send reverberations throughout the network as well. So we're zeroing in on that. I say confidently, but it is something we've had to talk about a lot.
Yeah.
And it's a work in progress, but I would say it's some sort of an event that has the potential to change people's views on the candidates. And that's very a loose definition, but when we think about it in terms of, you know, examples, as Elizabeth pointed out, it could be a fundraising quarter, it could be a debate, but then thinking about it in terms of what Linda asks in terms of the follow-up questions, right? It's like, what does that mean for the model, right? And so one of the interesting things about that is that, you know, when we have these discussions, our research and other research in our field talks about like these 1 or 2 week lags. And so when Linda asks, okay, well, how long does this shock last? It's like, okay, well, what would represent 1 or 2 weeks in our model, right? So we think about things like that. So we have to make that transition. And so thinking about the definition and making it consistent with, you know, how it ends up being modeled is obviously still a work in progress, but it has to happen together. We can't just come up with a definition and then try to model it. And then if that model doesn't accurately reflect that definition, then we're not saying the same thing. So.
Yeah, no, thanks. Kara, it looks like you have a question, and then we should probably aim to move this toward closure a little bit.
Sure. I actually have a kind of a two-part question. Number one, how do you foresee this data helping candidates in the future? And then I guess the second part of that would be, what other disciplines could this modeling be applied to?
Colin, I think the first question is for you. I'll take the second one.
Excuse me. I breathed too quickly there. So, you know, I think it's interesting that we have to keep in mind that what we publish could be used by anybody. So we really have to think about how it can be applied and how it can be interpreted. One of the examples that I think of is political science research that used experiments talking about how if we let your neighbors know or let you know that your vote is public, not who you vote for, but whether or not you voted for, it really gives you a kick in the rear to go ahead and vote. But it also makes people really, really mad, right? So when you start saying, I'm going to tell all your neighbors that you didn't vote, don't be surprised when people get mad at you. So when we do these kinds of things, and this is very abstract, right? We have to think about not only the ethical side, but how will people interpret this? And so I would say that, you know, we want to think about, you know, the idea that public attention matters is something that people could say, great, then let's just go ahead and say anything we want to and do anything we want to for, you know, eyeballs. And that's one of the things that, you know, we're kind of working on it. It's been in the back of my mind. I know that Elizabeth has thought of it, as of some of my other co-authors on these papers, like at what point does attention actually hurt you? Mm-hmm. And so I think as, you know, we inform campaigns or people that are interested in this stuff read this, we always pose that in the conclusion. that there are going to be limits to this. So our hope is that people see this and understand there's this link, but you don't want to take it too far because, there's really the great unknown out there. So it can help. I would say that it's something that, because Google Trends, the data that we use is public access, that people can go ahead and see what it is that, people are associating with a candidate's name, and campaigns can certainly do that. So that's out there. It's a possibility for candidates and campaigns to use, which I think is a good thing overall.
And then just the question about the other disciplines that this modeling could be applied to. This actually came from the threshold analysis or modeling came from sociology, and the classic example there is a mob. And so Granovetter is the guy who's talking, and he says, what if you have 100 people and they're in a square, public square or something, and one of them picks up a rock and throws it through a window. So they basically saying each one has a different threshold for whether they participate in the mob or not. So the person who picks it up and throws the rock and throws it through the window, his threshold is 0. And if there's somebody whose threshold is 1 in that mob, then he's going to join him. And then it could end up, depending on how the distribution of thresholds go, or distribution in the thresholds go, it might end up being a mob, or it might just end up being 2 guys getting arrested for throwing rocks in a window. It doesn't look like a riot at all. And so that really, that example just sort of inspired me to think, like, wasn't sort of voting in networks or candidate preference sort of similar? And then I know they're using some really interesting data science techniques in history, taking documents and looking through them to see who knew who historically, to learn new things about history. And I mean, they're even doing this unstructured data analysis where they're sort of web crawling to see, and they're looking at tons of documents from World War II in Holland to see if they can figure out who turned in Anne Frank. And it's a historical question that's been going on for 70 years, and they're thinking maybe if we look through all of these, but we can't look through all of them because there's just so many documents, but the computer can, and it can do a little bit of analysis. That's getting a bit far from our model, I suppose, but I just wanted to talk about what some of these techniques for data science can really do for us historically.
Yeah, well, and that touches a little bit on the whole question of big data, right, which is part of what we deal with in our data science major and minor. So Linda, I wonder if you could just describe the interdisciplinariness of that major and minor a little bit so that people have a sense of what we're doing with that program.
Sure. Actually, Ryan is a perfect example of even though you didn't end up doing the major because it was new when you were finishing up. Ryan is basically a computer scientist who worked in the stats lab, who supported faculty throughout the university, including Dr. Swearingen. And that's really the key of what we designed the major to be, to give students a foundation in programming, because their data is out there, but it's messy. So you need to be able to write code to get it, to filter it, to organize it, to structure it, so that you could then analyze it. So, which is where the statistics courses and experience comes in. So it's that initial combination of foundation of computing, being able to write code, to work with data, and stats skills and data analysis skills. But what you find when you're a statistician or a computer scientist is you're always working with clients from lots of different disciplines. And so we included an interdisciplinary aspect to the data science major, requiring students to take a certain number of data-oriented courses in either political science or sociology, psychology. So it kind of surveyed the various departments in John Carroll to find data-oriented courses, just so that they're, as undergrads, learning how to learn other disciplines and how to basically be able to take these problem domains and actually produce a model for them. And Ryan, do you want to chat a little bit about your experience in the stats lab?
Oh yeah, definitely. I think the one of the projects I remember very fondly was the Dr. Swearingen and project of kind of looking into the electoral donations data set provided by the government. It's an open data set. But that really exposed me to not only kind of advancing my technical skills, you know, optimizing queries so they don't take 5 or 10 minutes to run on a big data set, but more importantly, what Dr. Sire was hinting towards, the idea of kind of learning a new discipline, learning how to work with Dr. Swearingen, who in this case was a client, you know, have an appreciation for political science, learn some of the terminology, and that went beyond just that project. In the exercise science department, got to learn more about some of the testing, fitness testing that they do on campus, and in some other areas and departments around the campus. So get to practice my my engineering skills, my statistical analysis skills, but also continuously learning new domains and areas that I otherwise would not have had an opportunity to do.
That's great. Well, Dr. Stiles, Dr. Sater, Dr. Swearingen, you are really kind of in the vanguard in terms of, I think, what a lot of future academic inquiry is going to look like in terms of putting disciplines together, helping our students to put disciplines together in the ways that Ryan and Kara and Darlene have talked about. So if you're interested in this first article, you can find it in the Journal of Artificial Societies and Social Simulation. And that's correct, isn't it?
Yes,
Yeah.
it is.
I wanted to put a T in there, but it's not stimulation, right? It's
That's
simulation.
right.
And, you know, I think what you've done to collaborate on this research, but also to carry that over into the classroom, teaching data science 100s or really kind of walking the walk with that is incredibly impressive and really valuable for our students and for John Carroll. So thank you for your work. And Ryan and Kara and Darlene, thanks for joining us. And we're proud of everything that you have done and will do going forward. So it's a pleasure to have you join us. And thank you to all of you for joining us today.
Thank you, Dean.
Thank you.
Thanks.